Without mathematics, there's nothing you can do. Everything around you is mathematics. Everything around you is numbers. Shakuntala Devi shows us the beauty and universality of mathematics, a creative and abstract way of thinking. Therefore, let's join our group through this video to learn more about the application of calculus, advanced math. Calculus, also known as advanced math, is one of the most important parts of mathematics, with complex concepts and formulas full of appeal. Widely used in many different fields, calculus has become an integral part of modern life. A brief overview of the formation history. Modern calculus was developed in 17th century Europe by Isaac Newton and Gottfried Wilhelm Leibniz, independently of each other, first publishing around the same time, but elements of it appeared in ancient Greece, then in China and the Middle East, and still later again in medieval Europe and India. Now let's move to the first part of content, which is about application in life. Calculus is a rich and diverse treasure of mathematical knowledge, containing in it very practical and useful applications for human life in many different fields. To understand more about the magic of calculus, let's explore the specific fields where calculus has contributed to solving difficult problems. In physics, used to model and predict physical phenomena. Math is used in statistical analysis of weather data. For example, calculate the trajectory of objects located in the solar system. Math is used in reference coordinate frames of fly-around motion, or to model the motion of liquids in a duct. In medicine, medicine is used to analyze and predict physiological processes in the body. Example, modeling post-operative pain relief or to predict the rate of decomposition of a drug in the body. In design and construction, used to calculate specifications such as the durability of steel plates, the pressure in water pipes, or the slope of the curves on the drawing. In computer science, calculus develops and analyzes computer algorithms. For example, calculate the gradient of the target function in optimizing a machine learning model, or to calculate the derivative of a function in designing a search algorithm sword. So now we come to the next point, which is application in economics. Calculus is widely used in economics and is capable of solving many problems that algebra cannot do. In economics, calculus is used to research and record complex information, usually on charts and curves. Example, determining marginal revenues and costs can help business managers maximize their profits and measure the rate of increase in profit that results from each increase in production. As long as marginal revenue exceeds marginal cost, the firm increases its profits. And we have some typical math formulas. And providing a means for determining the amount of interest paid over the life of a loan. For credit card payments, calculus is used for setting payment structures and the minimum due amount by the credit card company by considering variables such as interest rates and fluctuating balances. Analyzing the market of goods services, supply function and demand function to represent the dependence of supply and demand on a commodity on the price of that commodity. This allows economists to assess the volatility of supply and demand in the market, thereby predicting future price and supply and demand trends. The chart shows the equilibrium of supply and demand. And optimizing business. Optimize business decisions by calculating the derivative of the cost or profit function. For example, optimize production costs by calculating the derivative of the cost function. Let's turn to the next issue, application in technique. Differential calculus is a tool for analyzing, calculating, and solving problems, requirements for technical improvement and development. Example, about fetal ultrasound, with the engineer, the person who makes the machine needs to know how to handle ultrasonic measurements to reset the simulation image on the screen, and in this new, complex mathematical transformations are needed based on differential calculus. Or, the application of integral is the construction of a balloon. Calculating the amount of air contained in a balloon will help us calculate the air resistance, thereby calculating the maximum weight that the balloon can carry to ensure that people and goods in the storage compartment are safe. Calculate engine performance. based on parameters such as power, speed, and torque. For example, calculate the performance of an engine in a car. Now I want to describe application in mathematics. Calculus is a branch of mathematics that deals with continuous functions, limits, and related theories, such as derivatives, integrals, metrology, infinite series, and analytic functions. Calculus evolved from differential calculus, from which fundamental analytic concepts and techniques were developed. Derivative. Derivatives are considered a key tool that you can use the properties of derivatives to calculate, solve problems in mathematics, etc. For instance, derivatives will have a supporting effect, aiding in proving the monotony of the function, the condition for the process to be extreme, and in describing the variation of the function at a certain point. In addition, it also helps the calculation of the tangent of the plane curve, the equation of the tangent. Integral, playing the role of fundamental key analysis in calculus. Integral is used to measure the area of a plane figure and calculate the volume of an object. In addition, it is also employed to determine the odds allotment of variables and calculate the chances of events over a specified domain based on the probability distribution. Differential. A branch of calculus, the study of the rate of change of a function when a variable changes. Appears in many areas of mathematics, such as complex analysis, functional analysis, differential geometry, measurement theory, and abstract algebra. That brings us to the end of our presentation. Let's come to the conclusion. Calculus contains interesting, complex ideas and formulas that require creativity and logical thinking. The applications of calculus are rich and varied, from velocity calculations, acceleration, and curves of moving objects to the calculation of financial indicators, risk assessment, and future forecasts of markets and economic activities. Therefore, we shall delve into calculus together to become people with excellent knowledge and analytical skills, contribute to the development of society, and create real value in life. We'd like to thank you for taking time out to listen to our presentation, wishing you the best for the day ahead.